Hi folks, we're going to take a look at 8F from the Unit 6 assignment. So they give us these two functions, g of x equals cos x and j of x equals 2 to the x, and they want us to figure out which combination is going to give us these two functions 1 and 2. All right. Now notice here how I've already got composition, because I suspect it will be composition, because if I look at, say, adding these two functions, I know that over time, when I add 2 to the x plus cos x, it's going to start going upwards. If I subtract them, sort of similarly, it'll probably go upwards or downwards. If I try to multiply these two functions, well, right off the bat, I see that 2 to the 0 is equal to 1, and cos of 0 is equal to 1. So when I multiply them, I would get 1 at 0. And neither of these are equal to 1 when x is equal to 0. And similarly, if I were to try to divide them, 1 divided by 1, again, is still 1, neither of these. So I suspect that they're going to be that they're going to be compositions, okay? But good idea to go through all the possibilities, because there's more than just this way of combining these functions, all right? And as my first part of my justification is I'm going to do exactly that. I'm going to pick one particular point, because I noticed that at 0, they have different values. So right off the bat, if I take G circle F at 0, let's see what we get. We get cos of 2 to the 0, which is equal to cos of 1. And, well, I don't know cos of 1 exactly, but I do know that it lies between 0 and 1, all right? Or, in fact, between -1 and 1, but I suspect that it lies between 0 and 1. And look at that here. This number for graph 2 is some number between 0 and 1, whereas if I do J circle G of 0, I get 2 to the cos of 0. And of course, cos 0 is just equal to 1. That's equal to 2. And lo and behold, what do we have? That at 0, function 1 is equal to exactly 2. Okay, so here, therefore, this must be function 1. Okay, and by process of elimination, likely this is going to be function 2. Okay, but that's just one point. All right, and as we know, you can't make any sort of big claim by just using one point. Okay, so this is how I got my conjecture by looking at the value at x equals 0. Let's now try to find more evidence. Now, I hope that you recognize these combinations as something similar to what we did in class. All right, so let's start with function 1 here, and let's see what happens. Well, what's happening is that the outputs of cosine become the inputs to 2 to the x. And I know that cosine of x is going to be less than or equal to 1, greater than or equal to -1. Okay? And so the maximum possible value that this function is going to have, okay, so max of 2 to the cos x is going to be equal to 2 to the cos, it's going to be equal to, at most, 2 to the 1, because that's the maximum value cos x can have. And then the minimum of 2 to the cos x, we know, well, the smallest value it receives is -1, so 2 to the -1, which is 1/2. All right, and I see here that this function alternates between a maximum of 1 and a minimum of, well, hey, there you go, that's about 1/2. Okay, and we can make more arguments. We can say that cos x alternates from -1 to 1, so it's going to keep giving it these values that it's going to provide 2 and then 1/2 and then back to 2 and then back to 1/2. All right, so that's a fair bit of justification that function 1 is given by 2 to the cos x. And now let's take a look at function 2, see if we can make sense of it. All right, so what I'm going to do here is I'm going to look at the end behavior of 2 to the x. All right, because determining the cosine of these outputs might not itself be too simple. So I'm going to start looking at some of the other characteristics. So 2 to the x, as x goes to -infinity, approaches 0. Okay, so let's see what happens. Remember, those outputs now becomes the inputs to cosine. So as the outputs of 2 to the x approach 0, those become the inputs to cosine. And what happens to cosine as those inputs get closer and closer? Whoops, sorry, I just realized you can't see that. As those inputs get closer and closer to 0, well, cos x gets closer and closer to 1. And that's exactly what's happening with the function as x goes to negative infinity, is these values are getting closer and closer to 1. Okay? If I go to the other side, well, these numbers now start getting larger and larger. So larger numbers are being input into cosine. Okay, so what's cosine going to start doing? Cosine is going to start alternating between 1 and negative 1. However, the exponential function grows not at a constant rate, but grows more quickly as time goes on. So cos x is going to start receiving these inputs more quickly. And what's going to be the effect? The effect is that the period is going to get smaller and smaller and smaller. Okay, it takes less time for a cycle to complete because these numbers are being given to cos x at a faster rate. And I suppose one last justification is we know that cosine, whatever the inputs are is never going to give out answers that are bigger than 1 or less than negative 1. And that's what we see here, is the output of this function here is never larger than 1 and never bigger than, never larger than 1 and never smaller than negative 1. Okay, so again, a fair bit of evidence that function 2 is given by the equation cos of 2x. All right, so just to recap, if you're given a question like this, you want to consider all the possible alternatives. So I took a quick look at the arithmetic combinations, addition, subtraction, multiplication, division, and I was able to eliminate them by just looking at 1 point. Okay, once I decided that it was going to come down to composition, again, I used 1 point to make my conjecture, but then I had to give more evidence than that. So that's how I looked at what are the outputs of the first function and how are they affected when I input those into the second function. Okay, that's it for this one.